In number 1, we're finding the x and y intercepts. So let's remember that to find the x-intercept, we just set y equal to 0. All right, so let's do that. Here we're going to put y equal to 0. And we have a quadratic in standard form, so we'll try factoring. And this does factor x minus 5x minus 2. So we have two x-intercepts, x equal 5, x equal 2. In point form, we'd write this as 5, 0, and we write x equal 2 as 2, 0. Okay, because remember the x-intercept has y-coordinate 0. All right, now let's do the y-intercept. So to find the y-intercept, we just set x equal to 0. So let's do that here, and we have y is equal to 0 squared minus 7 times 0 plus 10, and that's equal to 10. So we have one y-intercept, that is y equal 10, and in point form, that would be 0, 10. Okay, the y-intercept has x-coordinate equal to 0. All right, in number 2, we want to test for symmetry of this equation, or this curve, x-axis, y-axis, and origin. So let's start with x-axis. And what we do is we replace y with minus y and see if we get the same equation back. So here we would have minus y is equal to x, square root 5x squared plus 2. So this is not equal to the original. So no x-axis symmetry. Let's try y-axis. So we would replace x with minus x. And we would get y is equal to minus x square root 5 minus x squared plus 2. All right, or y is equal to minus x square root. Now this, we can open parentheses, squaring this out, and we get 5x squared plus 2. Since the exponent here is even, minus x squared is just equal to x squared. This is not the same as the original. All right, so no y-axis symmetry. And now we'll try origin. We replace x with minus x, and we replace y with minus y. So let's do that. So here in this equation, we would replace the first y on the left with minus y. On the right, we replace that x with minus x, and the 5x squared becomes 5 minus x squared plus 2. Let's simplify this. We'll square this out over here, and again, because of the even exponent, we just get 5x squared plus 2. All right, now this, we notice that if we multiply both sides by minus 1, we do get the original. So let's do that. Let's either multiply, or you can think about dividing both sides by minus 1. Same thing, and we end up with y is equal to x square root 5x squared plus 2. So yes, we do have origin symmetry. All right, in number 3, we're finding the center and radius of this circle. And the way we do that is we complete two squares, first in the x's and then the y's. So let's rearrange this equation so that we have, we put x squared minus 10x together, and we'll put in a blank getting ready for completing the square. And y squared plus 12y next to one another plus blank. And let's put two blanks over on the right, so that whatever we add on the left, we're going to add on the right. Okay, now completing the square, half of 10 is 5, and squared is 25, so that goes here and here. And here, half of 12 is 6, squared is 36, so that goes here and here. All right, now let's factor these two. These are both perfect squares now. The first, x squared minus 10x plus 25, is x minus 5 squared, and the second is y plus 6 squared. And on the right, add these up, and we have 60. So we have a center of minus 5, sorry, 5, comma, minus 6. All right, whatever, if there's a negative here, the coordinate's going to be positive. If there's a positive here, the coordinate's going to be negative. So that's the center, 5 minus 6, and the radius is the square root of 60. And we can simplify that, the square root of 60, that's 4 times 15, or 2 square root 15.